it's not that, AI is uniquely dangerous in this respect or uniquely likely to lead to, sort of harmful, unbridled competition, but it's more that we have already gone through the lessons of other technologies. And, with the case of cars, it took decades of like gradually ratcheting up standards around fuel efficiency and seat belts and airbags and so forth. And we're in the early stages of that process for AI.
You're listening to Gradient Descent, a show where we learn about making machine learning models work in the real world. I'm your host, Lucas Bewell.
Miles researches the societal impacts of artificial intelligence and how to make sure they go well. In 2018, he joined OpenAI as a research scientist on the policy team. Previously, he was a research fellow at the University of Oxford's Future for Humanity Institute and served as a member of Axon AI's Policy Technology Ethics Board. I'm super excited to talk to him. So I was looking at your background. It seemed like you did you had kind of an interesting path into AI policy, right?
Mm-hmm.
But were you originally working on kind of like energy and climate issues? Do I have that right?
Yeah, exactly. Yeah. So in undergrad in DC, and then for a little while after I graduated, I was working at the Department of Energy and other sort of like think tanks and stuff in the broad area of energy and climate policy. And I ended up sort of wanting to go to grad school because I wanted to do more research and less sort of administrative and sort of support for like sort of boss support type stuff. I was like a special assistant was my role, and it was, I learned a ton from being in government and working on something that was super hot at the time. Like energy and climate policy was a big deal. People are talking about it way more than AI or anything like that back in the day, and it was super enlightening. But I also eventually concluded that while energy was important, there wasn't as much sort of to be done in terms of research to move things forward. And AI was this sort of more fresh, green field in terms of research, and that it wasn't just a political problem of like getting the right thing to happen, which I think is arguably the case with energy and climate change now, where we have some good understanding of the policy issues, not everything, but we have a decent understanding of what needs to be done. And it's largely a matter of political will, whereas in AI, it's not even clear like what we want and what we, what should be done, let alone how to get the political will. So that felt like a more exciting opportunity for impact on the research side.
I'm curious, having kind of thought deeply about both, I guess like which do you think is more of a threat to the future of humanity, climate change or AI? Which worries you more?
Ooh. I definitely in the near term, I don't think, AI is going to sort of, end the human race or anything like that. It's still, relatively early stage, but we do need to think about the long-term risks of technologies as they're developed, whereas energy is something that's, a clear and present danger right now. And I'm hopeful that AI will actually help with addressing it. But yeah, I think energy is sort of a sort of known long-term time scale issue where we know that there's a bunch of things that need to change in order to get on a good trajectory. Whereas AI is sort of we know that we're not in sort of imminent danger of like all jobs being automated or killer AI taking over the world or something. But we see these sort of trends, and they're more uncertain in how quickly they'll develop. So I think we're actually, despite all the uncertainties with, climate change and, energy technology innovation, where we, don't really know what's going to happen in a few decades, we actually have like more reasonable error bars for that than we do for AI, where it's like experts are all over the place in terms of thinking things will be, solved in the near future or taking centuries. And I think it's actually harder to be very confident about AI than energy and climate change.
Well, I guess, where do you like kind of like when you say sort of like medium or near term, medium term, do you feel like there's like a serious possible issue with AI in the next, like, say 50 years?
It's really hard to say. I think we should try not to be too confident in what where the trends are going to go. Like just in the past few years, there's been a lot of technological progress that people have found surprising. Like very few people were sort of expecting as much progress in things like machine translation and natural language generation as ended up happening. And similarly, things like image recognition have just gone from like, oh, okay, it's like in the human performance, ballpark to like, okay, now it's superhuman. In some metrics, it's not superhuman across the board, but on sort of well-defined tasks, we've made a ton of progress. will that lead to, at some point systems that are harder to control or that might cause unintended side effects in, increasingly large sort of context where they're deployed? I think it's hard to say. I think we should think of this as something that, where the stakes are going to rise both as the capabilities increase and also as the sort of use cases grow. So even if AI sort of doesn't progress much in terms of capabilities, it seems like there's economic pressure and other sorts of reasons why it's going to be deployed in more contexts. And as those sort of contexts get more dangerous, like the stakes are going to rise. So we're already seeing AI applied for things like predictive policing and face recognition and things that are highly sensitive, and also things like search engines and recommendation systems that are actually materially affecting what information people get and what products and services they. It's definitely the sort of thing that the stakes are high and getting higher, but it's hard to say what the sort of endpoint of that evolution will be. And I think the key is to sort of think ahead and be at least a few years ahead in terms of what sorts of problems we're anticipating, so that we're not caught off guard. So things like misuse of AI systems, I think we should not sort of wait until the risks have materialized, but instead think about what can we do at the design phase to make these problems less severe. Can we develop detection systems, those sorts of things. So I don't think there's any sort of like inevitable risk. I think it's more like what is the how prepared are we relative to the capabilities and deployment that is coming.
Do you think there's something, I feel like a lot of these things that I hear about sort of AI, it seems like you could almost substitute the word like technology for AI and you'd kind of come to the same conclusions. Like, do you feel like there's something special about AI that like requires sort of more vigilance or different kinds of ethical concerns?
Yeah, I think it starts to get a bit, when there's more uncertainty and more sort of variation in the kinds of actions that systems can take, as opposed to just being, sort of deterministic code that does the same thing over and over, as opposed to dealing with uncertain inputs and, potentially a shifting distribution of inputs. I think the risks can grow when you're sort of moving from software to AI, but definitely there are all sorts of systems in society that are very complex already, even before. So I think the number of lines of code and sort of passenger aircraft are it's insane, and it's like super complex systems. So it's not like AI is suddenly going to lead to this new complexity, but rather there are sort of elements of AI such as the sort of processing of a wide range of inputs and potentially making decisions that previous software systems were not entrusted to do because we lacked sort of perceptual input and the manipulation outputs. So things like robots, for example, there are applications of AI that were just not possible if you don't have that technology. So it's I wouldn't draw a clean line between them. I see AI as sort of like an extension of information technology and software, and going back even further, things like electricity. And it's unclear whether that like cognitive element, like the sort of sense in which AI is about thinking as opposed to just following sort of rules blindly, and is that actually a significant element that introduces a lot of risk? I don't know whether we should be sort of AI exceptionalist, like treating AI like an exception, or just treating it as part of the spectrum of technologies. I think there are pros and cons of both, because you don't want to sort of ignore the growing capabilities in cases where AI can do things that previous technologies couldn't do. I think we're seeing lots of cases of just products that would never have existed prior to the current wave of AI. But we also don't want to sort of be hysterical and overemphasize the novelty when there are lots of technologies that have big impacts on people.
So do you have like do you have like an agenda of like some types of change that you want to like enact in the world at this point, or are you still sort of trying to like figure out like what you're trying to get folks to do?
Yeah, I'm still trying to figure out, the overall sort of agenda, but I think some of the key components are sort of cooperation between AI developers. I think is super essential in order to figure out, what the right practices should be and to hold one another accountable. And so for example, I did some work with Amanda Askell and Gillian Hadfield in a paper last year that talks about the need for cooperation in order to avoid a race to the bottom between AI developers. And so that's that. So insofar as, I have an agenda on that issue, it's avoiding, races to the bottom and avoiding.
Wait, what would
that mean?
What would a race to the bottom mean in this context?
Yeah, so like driverless cars is perhaps the most clear-cut case where there's an incentive to be safe, but there's also an incentive to get products to market. And I think in cases where systems are sort of deployed in a way that's premature in some respect, like not taking into account that there could be jaywalkers, for example, I think that's a case where there was a design element of the system that was not super thought through. And if you have people who are sort of overlooking these things and cutting corners in a rush to get products to market, I think that could cause harm for the whole ecosystem, not just causing individual crashes, but there are cases where sort of people following their own individual self-interest to sort of get things out there faster could lead them to cause harm and ultimately make the whole sector worse off. So that's why we need sort of regulations and other, as well as informal norms in the AI community that put things like safety and security and privacy and so forth first, so that there's some guardrails. So there's competition, but within certain guardrails. Because unbridled competition, I think, could lead to sort of lowering of the standards, and in an effort to sort of one up one another.
Do you mean like unbridled competition in terms of like researchers, or is that what you mean in this context, or
so I specifically mean in terms of sort of products going to market. So if there's sort of no standards for, say, driverless car safety, fortunately, I don't think there are any countries that have no standards. Their policymakers are aware of this need to impose some sort of guardrails, but if there's a world in which those standards are insufficient, and there's a need for and there's insufficient vigilance about how safe these systems are, then there's not going to be sufficient pressure to make sure that the sector as a whole moves in the right direction long term. And so it's sort of the trade-offs between individual interest and collective interest, as well as like short and long term, that I think could go awry. And that's why things like ethical principles that keep people thinking about the long term and sort of clarify what's expected of different actors, and also regulations that sort of impose some floor on what the level of safety or security should be for given systems are necessary in order to prevent it just from being a Wild West. So when I say unbridled competition, I just mean like in the actual deployment side of there needs to be some sort of process for making sure that unsafe systems are deployed.
And I guess is it so compare maybe AI, autonomous vehicles, to just the car industry, right? Like the car industry has all kinds of safety regulations that make sense, and do you feel that AI needs some sort of different kind of cooperation than other industries maybe need?
I'm not sure it needs anything different. I think it just needs to catch up to where other sectors are. So, there's a whole history of nuclear power plants, responsibly disclosing an incident in order for others to sort of learn from it. And similarly, there's a whole history of airplane crash investigations and regulations and so forth. So it's not that driverless cars or AI generally is this sort of new scary thing. It's more that we need to apply the same sort of approach as we have done in other technologies. So going back to your question earlier about sort of AI versus other technologies, I think this is a case where I see them as very similar. So it's not that AI is uniquely dangerous in this respect or uniquely likely to lead to harmful unbridled competition, but it's more that we have already gone through the lessons of other technologies. And with the case of cars, it took decades of gradually ratcheting up standards around fuel efficiency and seat belts and airbags and so forth. And we're in the early stages of that process for AI.
Interesting. Is there an industry where you think that's doing particularly well on this, or particularly badly?
Good question. I think driverless cars is not to be clear, is not an unambiguously bad thing. I think there's a ton of great work on figuring out how to make driverless cars safe, and there is some sort of informal cooperation going on among those developers, though it's kind of tricky, and due to things like antitrust laws, that prevent, too much coordination. It's not clear exactly, how much is happening and how much can happen. Other technologies, so I think, let's see, good and bad. I think there's actually been like a ton of really good work on things like image recognition and trying to characterize, robustness in that context. So, with regard to things like interpretability, we're much further along in terms of, interpreting, image classifiers than we are, with like language systems, for example. So just like, classifiers generally, I would say, are on like the more mature end of the spectrum, and that we have, clear sort of metrics for performance, and there's a lot of open source models to compare things against. And there's a lot of, sort of documentation of things like biases and potential, issues with robustness. So I'd say that's not to say that like all classifiers are good or something like that, but I'd say that, if you sort of look across AI, there are areas that are more and less mature in terms of, the rigor of, the rigor that people, are applying.
It does seem like, I guess it seems to me like AI does kind of come out of, more than other industries, maybe kind of comes out of like a research background, or maybe there is like a little bit more of a culture of, cooperation. Like it does seem sort of notable that so many models that people use in companies kind of come out of like open source projects or research papers. So it does seem like there's a fair amount of, at least like cooperation on the technology side, like maybe more than you'd actually expect.
There is, yeah. And there's an interesting question of, how long that will last, and, what are the like underlying drivers of that openness. One argument for, why it might be more open than you might otherwise expect is just that individual AI researchers want to publish stuff, and therefore that puts pressure on the companies that hire those people to, allow them to publish stuff. And I think that's like a very strong incentive, and the fact that AI researchers and engineers are sort of a scarce resource in the talent market, that gives them some influence over what the policies are at these companies. And there's also another argument for why it might be so open, is that it can benefit the companies to be open by getting people to use their frameworks, and it can make it easier to hire people in the future. But I think, I wouldn't sort of, want us to rest on our laurels here. And that's why, for example, in a report that my colleagues and I put out recently, we talk about the need for more generously supporting academics with computing resources, because we don't necessarily want to just, assume that, sort of those in industry will continue to, release products, and that, forever there will be this sort of pressure from below to do these releases, because there could also be cases where suddenly there's a huge commercial potential that's identified, and, they, companies sort of close up, or at an international level, there's sort of, pressure due to competition with China to sort of, damp down on publishing or something like that. There are all sorts of things that could happen longer term. So I would say, I'm glad that there is so much openness and collaboration today, but I think, given how much has changed in the last 5 years, I think we should be thinking about, what are the policies to make sure that it, continues in a good way.
So you're actually talking about, I think, a paper you just recently published, right? That towards trustworthy AI development.
Yeah.
I had some questions about that. Maybe you could jump in there. I thought it was like, and you were actually the first author of that paper. So I imagine you did a fair amount of heavy lifting, or?
Yeah, I was one of 5 first authors, so it was like super collaborative, both like at the whole authors list and at the sort of highest level.
Got it. Cool. Well, I guess, one thing I thought, it was kind of a provocative title, just the mechanism for supporting verifiable claims. I thought was just kind of interesting. And I think I kind of agree with the importance of it, but maybe you could sort of say the thinking behind that.
Yeah, so the basic idea in the report is that AI developers are sort of making all sorts of systems, and they want to sell them, or they want people to use them, and they sort of make various claims about these systems, like we did bias analysis, or they're robust in X, Y, and Z ways. And there's some claims like that are relatively easy to verify, like if you're in the case where it's like an open source system, you might be able, if you have sufficient technical expertise to replicate the results, reproduce a certain error rate and sort of verify that these AI developers are telling the truth. But there are other cases where it's not as obvious how to do that. For example, if it's a very compute intensive system, it might be harder for academics to scrutinize it. Or if there's sort of if there are claims being made about privacy preservation, but it's sort of this new fancy approach to sort of privacy preserving machine learning that there isn't a standard way of evaluating it, or it's a new library that hasn't been sort of subject to a lot of scrutiny for bugs. Those are cases where it's harder to verify the claims made by AI developers. So what we did in this report is try and take a very broad, sort of 30,000-foot view of like, okay, what is the problem here? And we broke it down into institutions, software, and hardware as the three sort of elements of an AI project that can contribute to sort of allowing one's claims to be verified. And then in each of those cases, we zoom into what are the specific interventions that can be made. Like in software, for example, we talk about privacy preserving machine learning and the need for more standardization and open source libraries around there, so that it's sort of reduce the skill requirement and increase like the clarity of how different systems should be compared. And interpretability, audit trails for safety critical systems, et cetera, are some of the things on the software side, and then as well as things at the level of institutions hardware that could incrementally it's not going to be solved overnight. We sort of don't want to overclaim what we're accomplishing here, but what we try to do is sort of survey what are the ways that people can show that they're actually being responsible, as opposed to just saying, hey, we're being responsible, we care about safety. How do you actually provide evidence of that? And are there ways in which there are sort of barriers to providing that evidence that we can make progress on?
Interesting. Yeah, I mean, I thought it was interesting. You actually sort of recommend that the government gives cloud like compute credits to academic institutions, right? It kind of struck me because that totally makes sense.
Or some other approach. Yeah.
I kind of thought. I mean, I actually remember kind of leaving academia to go into industry, and one of the I guess one of the real impetuses for me was the fact that like tech companies just had so much more data that kind of led to like sort of more interesting, just more interesting problems. And I do feel like when I talk to my friends at like Facebook or Google, they're like, they feel kind of more sophisticated in some specific ways, just having like dealt with like such like enormous data sets, and in a way that I don't think typically gets published. And I feel like OpenAI is kind of like one of the few places that, you clearly do like incredibly compute intensive stuff, but I wonder if you actually really deal with the same kind of scale of data sets, and if that might, if that might just sort of, I feel like there might be the case that like, a couple big companies are sort of getting a skill set that doesn't exist anywhere and doesn't really get published. I'm not sure.
Yeah, I mean, there's definitely a sense in which some companies have this sort of infrastructure in place for generating huge amounts of labeled or unlabeled data, and that puts them in a strong position to sort of do work in that area. I think it's also possible to do sort of cutting edge work with open source data through sort of existing data sets or scraping and sort of building your own data sets. So I wouldn't make it draw this sort of like hard distinction, but yeah, I think there are lots of ways in which industry gives opportunities that aren't necessarily available elsewhere, and that's part of what's driven the academics into industry. And part of where we're coming from in this report is like, is that a good thing? Are there ways that you can balance it? It's slightly easier to sort of say, okay, let's balance out the compute side of the equation than the data side of the equation, in part because a lot of the data is sort of private, and by nature it's just sort of really hard to get that out of these companies in an ethical way. But I think we should also be thinking about data and in terms of a differentiator between different sectors. And I would also like to see governments, in addition to providing compute credits or other means of supporting academics, could also be like building a data center or something like that. Also, generating labeled data sets is another thing that governments potentially do, because it's not clear that the sort of whatever is easiest to collect at Google or Facebook or Twitter or whatever is like inherently the data that we need to solve all the problems in the world. In fact, those data sets by default have lots of biases. So I think one potentially exciting area is sort of government support for data sets that could be used by large numbers of people and that are specifically designed to be less biased in certain respects, to have different distributions of bias that are sort of able to help a wide number of actors. And I think the fact that you can cheaply copy data is like a strong argument for this being something that governments do. It's like building a highway or something like that benefits a large number of people, and you can like try and exclude people from the highway and do tolls and stuff, but generally it's public infrastructure. And similarly, producing data sets that can be widely used is another thing to consider.
That's kind of a cool idea. I guess it does seem to me that like data sets have pushed a lot of innovation in ML. I mean, I also remember when I was a grad student, just this frustration of like, it seemed like the tasks that we worked on were sort of based on the data sets that happened to be available. Although I kind of feel like one of the issues that we had maybe was the, I mean, there were like sort of, collectives of people coming together to create data sets, but it would create a huge amount of, kind of bureaucracy in that data collection process because no one person, really owned it. And then I think it would end up being like a much bigger undertaking than it necessarily needed to be. So I could definitely see governments kind of having trouble, just kind of making a decision like, okay, well, what are we actually gonna, collect here?
Yeah, and it's not clear like what to be done. Like, you could also imagine in addition to compute credits, like giving, academics data labeling credits that just, allow them to sort of, go to some, third-party service and pay for some amount of data. And I think there's probably a role for that in the same way that there's also a role for sort of, big public data sets that a bunch of people are using for, some general class of problems. So I think, you ideally want to reduce the barriers to entry on, both for generating these big useful data sets, but also for making sure that people have access to more tailored data for their own needs.
Hi, we'd love to take a moment to tell you guys about weights and biases. Weights and biases is a tool that helps you track and visualize every detail of your machine learning models. We help you debug your machine learning models in real time, collaborate easily, and advance the state of the art in machine learning. You can integrate weights and biases into your models with just a few lines of code. With hyperparameter sweeps, you can find the best set of hyperparameters for your models automatically. You can also track and compare how many GPU resources your models are using. With one line of code, you can visualize model predictions in form of images, videos, audio, plotly charts, molecular data, segmentation maps, and 3D point clouds. You can save everything you need to reproduce your models days, weeks, or even months after training. Finally, with reports, you can make your models come alive. Reports are like blog posts in which your readers can interact with your model metrics and predictions. Reports serve as a centralized repository of metrics, predictions, hyperparameters tried, and accompanying nodes. All of this together gives you a bird's eye view of your machine learning workflow. You can use reports to share your model insights, keep your team on the same page, and collaborate effectively remotely. I'll leave a link in the show notes below to help you get started. And now, let's get back to the episode.
I'm curious, just like a little bit jumping around, but what do you think about it seems like OpenAI has actually been a real driver towards using like kind of more and more compute on these different challenges. Kind of makes it hard to reproduce and makes it potentially some environmental impact. Like, do you have any like thoughts on that?
Yeah, so I think it's a really good question, and I think I've liked a lot of the publications on this topic, like the paper Green AI from some folks at the Allen Institute was a good investigation of this topic, and lots of other people have been calling attention to it. I think in general, my view is that all things being equal, we want would like to sort of not use more compute than is needed for solving a given problem, but there's some ways in which it's not as urgent or as bad of a problem as it might at first appear, such as the fact that the sort of pre-training step of like a large generative model, for example, only needs to be done once, and then it can be fine-tuned relatively cheaply or even used in a zero-shot fashion by millions or billions of people. So I think it would be sort of strange to look only at the sort of training side and not also the inference side. And I mean, your question wasn't about one or the other specifically, but I would just, flag the, the difference between the two in that, say like, Google using BERT for search engine, search result ranking, for example, like presumably almost all of the compute cost there is on the inference side rather than the training side, just because, it was originally like, a few $100,000 or something for the training, and now it's being used at large for billions of users. So that's not to say that it's not an issue in terms of, the environmental impacts, but you also have to look at, the full sort of, chain and think about inference. Whereas I think a lot of the attention so far has been on things like, big training runs.
Yeah, I guess that's a good point. I mean, I wonder why that is. I mean, I actually sort of felt like when I kind of looked into, like, did my sort of, back of the envelope calculations on the whole thing. And it seemed to me like, even if you took all the graphics cards that are made and like ran them at all times, it wouldn't be near the environmental impact of just like regular data centers. But I guess like I guess the trend line is certainly like, it's scary, right? Because it's like this exponential growth and, volume of usage. And I guess maybe it feels like there's sort of a more natural barrier on the inference, because it's like, I don't know, why does it feel like that? Maybe because companies are kind of doing it. They probably won't. It's just, I guess it sort of seems like there's some limit to the inference, whereas the compute seems to be, the training seems to be skyrocketing. At least that's my impression.
Yeah. Yeah, and like another, I think that's right, in that we haven't really seen many like big models being served in production, and generally there's like a lot of optimization pressure to like keep things limited there, whereas in like training and research it's a bit more like everything goes, and trying out things to see what works. It'll be interesting to see how that evolves over time. Another thing I'd add is that I would also try not to like cast all of AI in a sort of broad brush, in that depending on the use case you could actually be saving energy. Like I think DeepMind and Google's use of DeepRL for controlling data center energy consumption, for example, is a case where you're actually able to reduce the net amount of energy used by applying some AI upfront.
I guess one question I asked Jack, and I thought his answer was really interesting, I'm kind of curious about yours, is the whole thing around kind of not releasing the GPT-2, the biggest GPT-2 model. Well, maybe I'll say what I thought about it. I didn't even tell Jack this. This is sort of my impression. I mean, I don't view myself as sort of the expert on this stuff. And I think at first I kind of felt like sort of being like, openness seems like really, really important to me as just like a core value of, like, it sort of feels to me like if people are going to do stuff and call themselves like OpenAI, they really should be kind of making their work, erring on the side of making their work public. But then I thought, well, it's kind of interesting that, they've sort of chosen to think about the impact of releasing this, and, kind of making like controversial stance here. That also I thought, like, I wonder, and maybe they're right. It certainly seemed to me at the time like a really powerful language model could be used in bad ways. And so I think I didn't feel so sure myself, about what I thought. And then it sort of seemed like it didn't really matter, because like, other models came out like, like a month or two later, and like, it almost seemed like maybe the most surprising thing is that there weren't more applications of such a impressive looking, technology. I don't know why I started. I just, that was my thing. I'm kind of curious from the inside, like how it felt for you. And then, if there were any like lessons learned on it.
Yeah, so I mean, from the inside, we also, felt very unsure what to think, and we tried to sort of at each stage, like, say, clearly, like, well, we don't know how dangerous this is, and we got this information, and we're sort of we were trying to like reduce the shrink the error bars over time in terms of both like beneficial uses and potential malicious uses. That's not to say that we eventually converged on a total on an overall conclusion of like, okay, this is like definitely good for society, but we started with the default of openness, and sort of these concerns arose in terms of people building proofs of concept of writing reviews for Amazon, for example, and like that seemed pretty scary, and writing sort of fake news stories seemed pretty scary. And ultimately what we sort of ended up doing was taking an incremental approach of sort of releasing progressively larger versions of the model. And obviously, if we could sort of go back in time, we would sort of take all the insights that we have now and sort of feed that into an earlier stage in the process. But What I think what we ended up doing, I think, was like a reasonable approach in the sense of like, if there's a potentially irreversible decision like releasing a model, it makes sense to be a little bit cautious, before you do it, if there are ways that you can gather more information. I think there are ways you can get some information by doing things like human studies, and we worked with external research to run to outputs by people and sort of statistically study the differences across the model sizes, and that informed some of our decision making. But ultimately, it's really hard to sort of answer these questions because so many uncertainties about the economics of it and the motivations of bad actors. So I think it's an ongoing issue that couldn't really fully resolve last year.
Do you feel like you really got new information that like informed decisions like along the way? Like what kind of information did you collect, and what different information could you have gotten that would have made you make a different choice?
Yeah, so just as a concrete example, we were like very unsure what the sort of scaling relationship is between sort of model size in this GPT-2 regime of like 125 million to 1.5 billion parameters. We weren't sure what the sort of relationship was between model size and convincingness or ability to be coherence and clarity and so forth. And we had a rough sense that there's this sort of smooth-ish relationship. As you grow in model size, it takes fewer and fewer tries to get a given result. So, less cherry picking is required, for a given fixed level of sort of performance. And that seemed to be true, but we weren't sure, okay, but we also weren't sure, like, okay, for a given level of cherry picking, what's the level that you can achieve? And what we ultimately found was that there actually wasn't a huge difference between the two largest model sizes, and that was one of the factors that pushed us towards releasing the 1.5 billion model, when otherwise, like, if there had been more of a gap between the two, then that would have felt like there was more sort of risk in doing that release. And there were also other things happening, like other people releasing models, and we're able to do some sort of comparison between them. So we were trying to absorb as much information and generate as much information as we can. But yeah, overall, that's like probably one of the most clear-cut cases where like the like diminishing marginal risk as you sort of increase in model size was a reason why we sort of felt like for scientific reproducibility reasons, other reasons, the benefits were sort of outweighing the cons there, because there wasn't much increase in risk, but we also were seeing significantly improved performance across a range of sort of standard NLP benchmark. So it seemed like it was a non-trivial increase in utility from a research perspective, and also would allow people to start grappling with some of the issues involved in training these large models, but also didn't seem to be a huge marginal increase.
As someone who worked on natural language processing a while ago,
Mm-hmm.
I mean, I thought that in my view, the GPT-2 results were like incredibly impressive, and I thought at the time, this must have been about a year ago,
Mm-hmm.
That the applications would be enormous. And I think actually the applications have been kind of subtle. Like I've noticed I've noticed translation systems working a little better than they used to. And there was that like crazy adventure game that that I played, and it was like kind of fun. Yeah. And I've seen like people like suggesting plausible domain names for your business, and we see on our website we see a lot of models come through, and so we do see people using the technology, but
Mm-hmm.
I don't think that like my mother has like noticed a difference in her world. Maybe that's not surprising in retrospect, but it's funny how it's like it seems like there's this huge leap and I feel like in the vision stuff we maybe feel it a little more. Like, I feel like, face recognition is it feels like a little more, ubiquitous to me and scary. And at least I notice in my camera, it like somehow finds, people's faces and things like that definitely couldn't do a few years ago. I'm not sure. What do you think about this?
Yeah, well, I tend to, sort of think in terms of, general purpose technologies that, could be misused or could be used for beneficial things. So I basically say the same thing, that I was saying about the risks. So we have some information about, the fact that you can produce coherent text in some contexts, and that seems like it could be used for lots of, commercial and creative applications, and also could be used for some malicious applications, but we might just not be at the level of performance for either of those domains where it sort of is a straightforward replacement of what people were already doing. So I think we'll get there eventually, and that language models will continue to proliferate to a bunch of different applications, and including on the edge and in the cloud and all sorts of contexts. But I think there a few things need to happen. There needs to be more reliability and sort of higher higher performance compared to humans on some tasks where it's just not going to make sense to replace when it's to replace a human or augment a human if it hasn't yet reached that level of performance. And generally, I think we also need to figure out what the right workflows and ways of leveraging these systems look like, because I don't think it's just replace a human with a language model. I think that's one of the sort of more naive sort of uses that you can do, but that depends on a very high level of performance and the right kind of use case where you don't need sort of online monitoring. But I think there's also other cases like sort of writing assistant where the fact that it's not 100% reliable is not is not sort of a deal breaker. But if you're able to sort of get humans in the loop to sort of provide feedback on these systems and sort of choose among a few potential outputs, like both for beneficial and malicious purposes, I think that could be a game changer. So I think we'll see further progress both on the technology and people finding better ways to use it.
Interesting. Does OpenAI do you sort of like continue to like push things forward, or are you sort of like, okay, we like made this model, like we're good? Like how does OpenAI think about that?
Yeah, we're still continuing to push things forward, and both in terms of trying to understand these models better, like the ones we've already built, and also trying to push further in terms of improving performance.
So here's another question that I always have about OpenAI, if you don't mind. I'm kind of curious what you think. So like, I think it's OpenAI has what's OpenAI's mission? Like ethical AI, something like that, right? What remind me?
The shorthand version is sort of build artificial general intelligence and use it to help everyone.
So I guess like it seems like a funny mix of sort of policy and building. Like, do you think it's important that those two things are together? Like I could imagine like should the people like I guess, well, how would you argue against this? Because I think I do think they should go together. I'm trying to think like with the other point of view, but it sort of seems like, well, like does policy and building really necessarily need to be combined? Like, is it even combined in most cases? Like, it sort of feels like the policymakers in general like aren't always engineers, right? Like why have a thing that combines both?
Yeah, so I think by default, a lot of people who are building powerful technologies are like de facto sort of policymakers, and that they're setting the defaults and the how people think of things, and they're sort of influencing what the early applications are and so forth. So I think you can't totally separate them. I think anyone who's sort of involved in technology should be thinking to some extent about their social impact. And there's also value to like division of labor, and that's why not every single person at the organization is like on the policy team. Like we have a policy team, and then we have a team. We have various different teams. So it makes sense to like have some specialization. But I think the reason why we think it's such a high priority is that we don't see sort of the impact of AI as reducible exclusively to the design of the technology. It's also about how is it, what sorts of policies are there in to constrain the use of it, and are there ways of distributing the economic economic upsides of it so that it's not only benefiting a small number of people. So we think that it's not just a matter of building the technology, but also making sure that it happens at the right time in the right environment with the right infrastructure. And so that's why we invest a lot in sort of advocating for policy changes that we think will enable a more cooperative, more responsible AI ecosystem.
What like among like I'm sure you have like a group of like AI ethicists or policymakers that you hang out with. I'm curious, like in those circles, like like things that I hear from people that are interested in AI, they seem like very like they don't seem very like controversial for me. It seems like people want like fairness, and they want like openness and transparency, and these things all seem like really like sensible, wonderful things to me. But I guess like where are there like disagreements? Like are there like different like factions you think of people like thinking deeply about this topic?
There definitely are. Yeah. So I'm not sure I'd say factions because I try to like,
Sure.
build bridges and stuff like that. But there are definitely like differences in emphasis between people who are sort of focused on, immediate ethical concerns around things like bias and surveillance, sort of one end of the spectrum. There are probably multiple spectra, but, that's one end of one spectrum. And on the other end is people who think, existential risk from, AI systems that are too powerful to, control, or unless you've sort of thought really hard about it in advance, then, by default, things can go bad. That's the thing you should focus on and devote 100% of your attention to. So I think, personally, I find myself somewhere in the middle, and OpenAI as an organization finds itself somewhere in the middle in that we are thinking about both bias and long-term safety, and thinking about present systems and AGI. And I think there's a lot of I don't think I don't think that in terms of factions, because ultimately like both sides are just trying to like figure out how to make sure this technology helps people and doesn't hurt people. And in fact, often the conclusions in terms of the actual policies you recommend aren't that different, depending on whether you're focused on the immediate term or the long term. So I see it more as sort of a spectrum, but there are definitely people with different emphases.
Is that like cop out? Like, I don't know. Like, I feel like if the ethics is interesting, it must have like there must be like controversy, right? Like inside, have there been decisions like internal to OpenAI, or even just sort of like philosophical discussions where like people really take like strong like different stances? Like, because I feel like when you put it in this general sense, it's like, who would argue that we shouldn't make AI safe, and who would argue that we shouldn't make AI biased? But I have a feeling like when you zoom in on like what that really means, there must be points where they come into conflict.
Yeah. Oh, there's yeah. And to be clear, you had asked me about factions, so I tried to give you a map of the factions.
Sure.
But I think there's also like within the factions, and there's also all sorts of debates, and they're not like consensus factions. So let's just take like the short-term issues. So I think among the people who are focused on short-term issues, I think there's sort of another sort of spectrum of people who are on the one end thinking, okay, like we have to figure out how to do this right in sort of each case, and figure out what the right norms are, and sort of they see it being like both intrinsically important and symbolically important to get issues like bias and so forth sorted out as soon as possible. Whereas there's and so that's sort of the like the like hardcore, like let's make sure that we're not causing harm. So like maybe the like Hippocratic oath end of the spectrum of like first do no harm and like take stuff like bias super seriously. Then there's another there are also lots of people who are building systems that are sort of focused on getting products to market, and they're focused on sort of releasing systems that can inform research. And in the case of GPT-2, we saw like some of the tension between these perspectives of like there was potentially a tension between avoiding causing harm on the one hand, and enabling people to understand our research and verify our claims, and sort of build new systems. And so you could maybe say like Hippocratic, oath end of the spectrum, and the like move fast and break things end of the spectrum. And I think there's like an element of truth to both of them, in that like shouldn't be harming people on the one hand, and also like this technology needs to be iterated, and there needs to be sort of publication and sort of models getting out there in the world in order for there to be sort of learning by doing, and ultimately figuring out how to solve those problems. So definitely you could say conflicts there. And in the case of GPT-2, there were definitely a bunch of different perspectives internally at OpenAI, and ultimately we tried to wrangle that into a consensus view. But you can see the like ambiguity in the fact that we were like hedging a lot of our claims, like we're not sure how dangerous this is, and we're sort of doing things one step at a time. That was because there were actual like different competing values at stake. Like there was like I wouldn't say it's like totally zero sum, but there was like some zero sumness between sort of like avoiding potentially causing harm if it turned out that GPT-2 was very dangerous, and allowing people to verify the technical claim.
Yeah, that totally makes sense. When you think about, I think you mentioned that you don't really have a good sense for like what all the policies would need to be to like on like climate change, like where it's pretty maybe more clear what the sensible policies are.
Mm-hmm.
Are there some things policies that you would enact if you had control, or if you could like recommend a few things to say like the U.S. government, like what would those things be?
Yeah, so some of the stuff that we flagged in the toward trustworthy AI development report, I would definitely consider here. So stuff like compute support for academia. I think generally, like at a super high level, one policy change that I'd like to see is sort of more robust support of academic research, and including not just compute, but also things like data and just sort of funding for academics, so that they're not constantly like writing grant applications and I think there are lots of inefficiencies in the way that the American academic system works currently. So like more long-term funding of work in areas like safety and security and privacy would be good. Sort of more support for working on things like bias. Because I think what we're currently kind of in a regime where there's a little bit of funding here from Department of Defense, there's a little bit of funding here from National Science Foundation, and then there's like everything that industry is doing. And what I'd like to see is a world in which an academic or postdoc or something like that doesn't see a big trade-off between sort of working in industry versus academia in terms of the resources that they'll have and the amount of freedom that they'll have. Because I think we'll see both faster progress in AI and more creativity if people are able to think long term in different sectors and not be sort of constantly fighting over money. But also there are sort of areas that by necessity need to be worked on over the long term. So things like safety, for example, you want that to be like always an option for ambitious grad students to work on that, but it's actually not really the case today. A lot of the time today, like one could go to grad school and not find an easy way to work on AI safety because a lot of the grants available are at Department of Defense on X, Y, and Z or something like that. And they do fund some safety stuff, but I would like to see like more balancing between the civilian and defense side, and also sort of more more robust long-term funding for academics.
I mean, that makes sense. But what about regulation? Would you like push for? I mean, besides just like what kind of more funding, would you would you want our government to enact some like laws now around like putting guardrails around like AI research or deployments, or would you want them to kind of wait and see till there's more information?
Yeah, it's a good question. I think my answer is like yes, they should do some stuff now, and other areas they should wait and see. So I think in areas like driverless cars, for example, there's like already a sort of clear reason to act quickly and develop sort of sector specific regulations. I think another area where I'd like to see more progress in developing clear guidance for sort of entrepreneurs and others is health applications of AI. So where there's like some effort to sort of figure out how AI systems should flow through the FDA, for example, and what should that review process look like. I think that's an area where it would be beneficial to see sort of more investment in capacity and expertise in the government, so that they have a better ability to sort of process these applications, and also just like clearer sort of structures for getting AI systems through sort of regulatory process like that. I think could be very valuable. I don't know exactly what the details of that should look like, but generally that's something where we do not want people putting out sort of health applications that are causing harm, but we also don't want we don't want zero health applications of AI. So I think that's an area where like some guardrails in order to give people like long-term sort of clarity, so it's not just like a black box of, oh, will my system be able to be deployed in like a year or two, but sort of long-term signals, I think would be very valuable.
Yeah, that makes sense. Cool. Well, we always end with two questions. I'm curious how you're gonna what you'll say about these. So the first one is it's kind of broad, but kind of off the top of your head, when you think about all the sort of like topics in machine learning, what's the one that you think people don't talk about enough? Like, what's the sort of like underrated topic that you'd like to kind of push people to go maybe learn a little more about?
I mean, I think one super interesting thing is like detection of language model outputs, and I mean this is sort of partially me being biased from working on GPT-2 a lot, but there's actually been like a ton of super interesting research on things like how the sampling strategy relates to detectability and how like model size relates to detectability. And one area that's like super uncertain is how fine tuning relates to all this. So you can imagine a world in which like GPT-2 or other systems are used to generate like homework. And this is just someone was giving an example of this on Twitter just earlier today that I saw, and it's like people are using it to cheat or to generate phishing emails or something like that. I think it's a really interesting question, like what the sort of limiting case of like detection of language models is. Like, will it just always be like
who wins that arms race?
Yeah, who wins that arms race? And also, like, are there steps that you can take to make it more winnable from the defender's perspective, like watermarking or something like that? Because I think it's I hopefully it's not like a super urgent issue, and that hopefully hopefully there aren't that many people actively trying to weaponize these systems or whatever. But I think there's been a ton of work by Google, the Allen Institute for AI, University of Washington, OpenAI, and elsewhere on trying to like push the state of the art forward. But we still don't have a general theory of how all these things fit together.
Interesting. What is the state of the art? Is it like, can you generally detect these models?
Yeah, so the state of the art is like around 95%-ish detection of where it's sort of actually, so we use a Roberta model actually in order to detect GPT-2. So when we released our sort of newest and best system, we're actually using a smaller model to detect the outputs from the larger model. So that's one of the things, is that like it isn't one of the early findings from folks at the University of Washington and Allen Institute was that models can detect themselves, and that this was sort of an argument for releasing. We eventually found that like sidestepping and trying a different model architecture than using it to detect the original one sometimes works better. One of the things that we found is that it's easier to detect the smaller models, which is maybe not surprising because they're just sort of worse in some respects, and they might be making more errors that are sort of catchable. But yeah, that's sort of what our initial findings have been. But there are other people who have found other really interesting things, like what are humans picking up on versus what sort of AI systems are detecting. Like AI systems can detect weird stuff like distribution of adverbs versus nouns or something, and like, oh, therefore it's fake. But humans are not looking for those kinds of things. They're looking for is it saying something that's like incoherent, or is it repeating itself, or things like that. So we've that's one another interesting finding, is that humans and machines are complementary in terms of how they detect things.
I guess that makes sense. I mean, maybe I'm overconfident or out of date, but I feel like I can still detect these models pretty reliably by noticing that they make no sense.
Well, yeah. So I guess it depends. Yeah. So I mean, there's a good sort of like game that you can play to detect like fake versus real Trump tweets, and there are a few other sort of like quizzes like that I think are worth trying. It's sometimes harder than you might think, at least like in the context of fine tuning.
I guess also the Twitter genre is really kind of pushing us to. Yeah, I could see Twitter being a tough medium to detect human versus machine, but I feel like over like a few paragraphs, I think I could do it. But now I want to try.
Yeah, the over a few paragraphs part is critical, because that's like one of the like robust findings, is that both for humans and machines, it's like easier to get more context and more long information. So that's potentially like it's actually kind of good in that respect that Twitter recently went from 140 to 280 characters, because that's like a sort of sweet spot in terms of like detectability. It makes it a bit easier.
Well, maybe our popular culture is nudging us more towards the language of machines than machines are learning human language.
We'll see.
Okay, last question. So this is kind of more, I guess it's like a more for practitioners, but I think actually I'd be curious your take on it. So when you look at things at OpenAI or elsewhere, and you look from like sort of the conception to creation and deployment of like a complete model, I guess like where do you see the bottlenecks happening? Like what's sort of the hardest piece of kind of like getting something done and out the door?
Good question. I mean, it seems like a lot of it is, finding the right hyperparameters and the kind of stuff that y'all are, trying to help out with is sort of getting the right hyperparameters. Obviously, like compute is a bottleneck, if you, don't have enough compute, but I'm sort of thinking in the context of AI where you have a decent amount of compute. Data is definitely always an uphill battle. Like it's, even if you're, have sort of good engineers who are, good at, gathering and cleaning data, there's always room for improvement. So I'd say I'm not sure that I'd call it a bottleneck, but like something to like push on is, quality of data. And just like ML, related to the hyperparameter thing is just like ML weirdness of like, it's just hard. It's hard to debug ML systems and like weird silent failures, which kind of related, can also be weird silent issues in data sets as well. But all of those lead to, various weird dynamics.
I mean, I do want to say for the record that I think I hope that our product helps people more with actually the kind of collaboration that you're talking about than like specifically tuning the hyperparameters. So I think like both are, important. But I'm really curious actually, because like you look at like, say that like we watched from the sidelines from far away OpenAI try to build like the robot hand and manipulate a Rubik's Cube, say. Mm-hmm. And just from like casually talking to folks on the team, it seemed like people felt like you were really close, and then it took like 2 years, but then it actually got done, but over like a long period of time. And what happens in that like year or two? Like what from your perspective, like what's like going on? Like it can't just be like tweaking hyperparameters, can it be?
Yeah. I mean, I should emphasize that I'm not a technical person, so I think and it's not not just like sort of sillily just sort of tweaking the hyperparameters.
But in a way, I think you might have like a clearer perspective than someone who's right in there doing it, because you're kind of like watching it from the outside. Like it's not. I'm curious what you think.
Yeah, I mean, in the case of robotics, like from my perspective, it felt like a fairly sort of smooth trajectory of like, every few months there would be some kind of, demo that seemed a bit more impressive. And it wasn't like, it's sort of nothing happened for years. It was like, maybe didn't solve the original problem for a while, but it seems like there's always, sort of, some area to push on. And I think you mentioned collaboration. I would say, just like knowing what sort of techniques to apply is like another part of it. So it's not, the hyperparameters per se, but like, knowing how to get, transformers to work in some new context, I think is like, non-obvious. And, the fact that there's not always, sufficient information in papers to reproduce things sort of requires you to do a lot of, sort of trial and error. And that's just sort of, how ML research seems to work, is like trying lots of stuff with hyperparameters and architectures and data sets. So forth, and just takes time.
Nice. Well, thank you so much for taking the time to talk. We'll put some of the papers you mentioned in the show notes. That was really fun. I really appreciate it.
It's great talking with you.